All right, so today, recently I've been looking at web frameworks, trying to pick which one I want to use, and I think I decided on Warp. So today we're going to do a quick overview of how to use Warp just by going through their repo and some of their examples. Let's get it. All right, so I mentioned that I was looking into web framework to figure out which one I was going to use for myself, and I settled upon Warp. Before I go into Warp, let me just tell you the little bit I did in terms of research, and that's more or less go to this web page. Are We Web Yet? Which is a page for Rust that's dedicated to describing where we're at in terms of web development and tools and projects and crates that we can use to build stuff. And it was recently updated. If you go all the way down to the bottom, scroll real fast, bam, it's been, the last time it was updated was November 14th, 2020. So as of right now, it's relatively recent. And if we scroll down to the first question of the page, we can get a sense of what the author's goal is. More or less, can I replace my Rails, Django, Flask already? And what they mean to say really is, can they replace that with Rust? And their answer is yes. Now, this page goes through a lot of web development, both front end in terms of WebAssembly and back end in terms of web frameworks, and database connections and stuff like that. But the only thing I really cared about was web frameworks. So I kind of just did a glance over of this. You can come back to this and read it on your own time if you find it interesting. Going on to the first paragraph, you can see that it has some big names. We have Actix, Web, Rocket, and then it has newer ones like Warp and Tide. I didn't do that much research. I figured something new was maybe kind of cool to touch, so I just picked one, and I went with Warp. So, what is Warp? So the crates.io page states, Warp is a super easy, composable web server framework for Warp speeds. Okay? The fundamental building block of Warp is the filter. They can be combined and composed to express rich requirements on requests. Now, I just want to take a moment here to describe a little bit or talk a little bit about filters, because that is seemingly different from other web frameworks. The way Warp sort of works, and we can get a sense of this in, let's go down to the example. You explicitly state your path via the path macro, right? And then you do a bunch of dot sort of like building notation to describe how you want to interact with this path or the requirements that this path has. And these things, these dots, including this map, are all filters. So if we go to the documentation for filters, and let me just scroll up to the top, we see that the trape warp filter, right? And I can show the declaration. It defines a bunch of stuff, but we can just scroll down. A filter can optionally extract some data from a request, combine it with others, mutate it, and return back some value as a reply. The power of filter comes from being able to isolate small subsets and then chain and reuse them in various parts of your app. Okay, so filters are more or less the building block of this web framework, and they allow you to like stack things on top of each other. And I'm gonna go through some of the methods real quick, just so you can get the names and have that in the back of your mind while we're reading through the code later on. We have and is a filter, or is a filter, map, which we already partially seen, is a filter, and then, or else, recover, unify, and I think there's a with, box, there's a few others here, and that was like the entire list, right? So just keep the idea of filters in your mind and how you're going to like isolate pieces of work and then like add on to it. All right, so going back to the example, right? And we can start from the top of the example. We have a requirement. Warp is dependent upon Tokyo, which is the asynchronous runtime of choice for them. And then the Warp version is 0.2, which it's young, it's new. And then coming down here, we see that we import the trait filter. We use Tokyo main just because this is part of Tokyo stating what is going to be the entry point into the function call, or the entry point into the program. There we go. and we have an async main, and here's the path that I was mentioning, and then here's a filter for a filter called map that will take in this parameter, which is the string, and then do an action on it. So we have a closure here, we pass in the string, and then we format it. And here you can see in the comments what is expected to happen. So we go to the path hello/warp. Warp is the string being passed in right here, and then it's to be formatted to hello warp, which is here. All right, so one of the good thing about warp is that it has a lot of examples, and in the link down here, which if you hover over it, it takes you to the GitHub page. And the GitHub page / examples has its own README file that describes what the examples, like they have a get it started section for the use cases, but more or less they link you to the example and give you a brief blurb of what that example is supposed to exemplify. Given that the main repo has examples, we can clone the repo and then start running these and poking around to see exactly how everything is working and fit together. So let's do that now. So I have cloned the repo, it's on my local machine, and I'm in that, my terminal has that repo open, and then on the right I just have the documentation still. And let's start with the hello one, just because it's the easiest and makes sure everything works. So if I want to run an example, it's cargo run -- example, and then the name of the example, and that one is hello. And it doesn't tell me what it's running on in terms of port, so let's just go to it. And here we see that this is warp any, which I believe just matches any request or call. And it just prints out hello world, and it's on port 3030. Okay, let me just open a new one. Am I here? Oh, I guess you're here. Localhost 3030 hello world, and it matches any, so I could just do / hello, same thing, /23 / gibberish. All maps are the same thing, so not that interesting, but it got the point across. So let's go back to these examples. They have one for routing that builds up more complex routing, and let's look at this file and read through it real quick. I should open a new tab. So for this one, going down, make it a little bit bigger. We import the trait because we need it. Tokyo main function. We start a logger. Okay. All right, so we have our first one, which is a get for hi, and it's exactly what we've seen before: path, and then mapping, which is the filter. Okay. So now they want to give us an example where we have multiple paths down the line, like hello / from / warp. And the way we define that would be using the path macro, hello / from / warp, and then mapping what we want to do once we hit that route. Understood? Now if we want to pass parameters into the path or URL, we can do that the same way. Here is sum u32 u32. So sum / u32 / u32, and then in our closure we have A and B, which corresponds to the first and second, and then we print some stuff out. We do something similar with times, just by putting things in the center. So u16 times u16, same formula for the most part. So one thing to note is that this is sum u32 u32, and this is u16 times u16, right? And then here they describe, oh shoot, those math routes should be mounted on a different path. Is that possible? Yep. So they do something interesting here, which is they create a new path, And it should be noted that this does not have the macro. You could use the macro, but it doesn't have it. And it says math, right? And then they do math dot and, which is a filter, sum. Okay. And that's going to create the first route here, where we have math slash sum slash U32 U32. So math, the path by itself, and then sum. And then down here, they did math dot and, which is the filter, times. So just building up again. So that goes to math, then U16 times U16. I see. And I know I mentioned it just now, but we should be paying attention to the macro, because they did not use it here, and seemingly at the very beginning they also didn't use it. I'm not exactly sure why they didn't use it there at the beginning, but for this line, if you did want to use the macro, there is a way of using it. And let me just go to the macro documentation real quick. So here's the documentation, and it has the macro rules, and they give you an example, which is what we just saw with the sum U32 U32. What they do note is that if you want to chain or add on to the end of this path, then down here you have to add a slash dot dot. So the path macro automatically assumes the path should include an end filter as in this is the end of the path. To build a path filter prefix such that the end isn't included, use this notation. So I'm pointing that out just to say, more or less, that in the routing one, if you were to make this into a macro, it would be incorrect, or at least it should be incorrect. All right, moving onward. By in a string. So here they're demonstrating a different way of creating your path. So they do the path, which is not a macro, and then they do dot and they do warp path param. And then they state what the param is here. So this param needs to be a string, and it gets mapped in, and it works the same way. So this is just an alternative way of using this format, because they could have just did a path the macro and then did by slash and then string. That is an option. This is just an alternative way of writing it. And it looks like there's an alternative way of writing the math route as well. So earlier we did math and then math and sum, math and times. Down here they did path math, no macro, and within and they did sum or times, which should give you the same path as the ones above. So this is showing the flexibility of the filters idea that they have embedded into this web framework. We can just write things flexible and compositable like this. And we can use an end filter, which we kind of know what that is because of the documentation we looked at. End filter means that the path should end. And it says, careful omitting the following line would make this filter match requests. Oh, I see. So the warning that they're giving us here is that if you use warp.path, path does not assume that there's an end. And as such, this math path is going to match this one, which is the math slash sum, yada, 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 and this one, because it doesn't assume an end. Now, if you put an end, then when the request comes in, whatever does the matching from the request to the route is going to know that math is not the correct match. It's going to continue onward to see something that is at least more specific. That makes sense. That is good to know. I think I made that mistake last week. I need to correct that. This I'm not too sure about. We can experiment to figure out exactly what that's doing. But let's come down to here. We have our routes. We do warp get dot and high or this thing dot or by or math or sum or times. I see. So again, this is showing the flexibility of the filters where we have all of these ands and ors, but also what they were mentioning here is that they created routes for sum and times that are sum and times, and those routes just tell you that the actual sum and times route has been moved to under the math path, and that is here. Those are here, and then math is also explicitly here. So when we run this, we should be able to test all of these out. Let's try it. And this is routing. And looks like it's already running. And let's start with high. Hi. What was the next one? Hello from warp. Let's do that one. Oh, and this is kind of tiny, isn't it? Can I make those? Hello from warp. Okay. Bind string. By and some sort of string. And out of curiosity, I want to see what happens if we put an integer here. I mean, it should just be characterized as a string anyway, because it gets passed that way, but I just wanted to be clear. And then instead of doing the math sum and math times, let's just do sum and times individually, just to see the other message that they stated they put there. So let's do sum, let's do 1 and 2. This route has moved to math sum. So that's exactly what we were expecting. And then math. And this is what we want in terms of math sum. And same thing is done for times. We don't have to check it. It's more or less the same code. But going back to this routing, the big takeaway, at least in my opinion in terms of warp, is that you can use filters like this. And to be clear, this is all just GET requests. We haven't really looked at posts yet, but I think they have an example for posts. Let's do that. What's a good API parsing data from a body request? Actually, let's look at this first. What is this one? Ah, this is a post example. Cool. So let's walk through it. We have Certi derive, which has the deserializer and serializer. I presume that is just for this employee, so that you could serialize and deserialize while you're making your request, like over the wire and when you receive something. We have warp filter because we need that trait. We initialize the logger. Cool. And here we go. We have warp post. So before we were looking at warp get, now we have warp post. And then we have a filter, and the path is going to be employees. So they use the filter to put in a path, and the param is going to be an integer. So they use the filter again to put in the integer, and I'm guessing that is rate. And the body only accepts content length of a certain size, which is another filter. And if you want to make sure it's accepting JSON, you just add that filter. And then they have the map to do the actual action. So we take in rate, which we already know is an I32. It's important to note that I believe in one of the examples they set the type here, but you can also seemingly set the type here instead. And then we have a mutable employee and that's just employee. Okay. And then we have employee.rate, warp reply, JSON, employee. And this is the serialization. And that's why you have employee has to be able to be serialized. So what does this mean, right? Because technically speaking, we have one parameter, and that's in the URL. But now we have a JSON body, and we have this thing here. The way I read this, and I think I ran this before, but we can go over in just a second, is that this is going to force the JSON content that has to be passed in the post to fulfill, or it's going to require that JSON to have a name and a rate. So just adhere to this struct. And let's try that out. Which example is this one? This one's body. See, routing, this one is body. So it says it's running. One thing to note is that it has a post, but it doesn't have a get. So if we do a get request, we should see some sort of error. Let's figure out what that error is by attempting. And it's localhost 3030, and it's employees rate. So let's just try that real quick. Move you over here. Employee rate. And it returns HTTP method not allowed, which is what we're expecting because we don't have a get for this endpoint. All right, so I realized that my initial GET request was incorrect because the URL was incorrect. I did employee instead of employees, so I corrected and put an S on it, and we get the same thing, so it doesn't matter there. But now we still need to do a post request, and I'm going to dip into Python to do that. More or less, there's a bunch of junk there. Let me clear that real quick. For Python, I'm just going to import requests because that's what I'm used to, and then the URL is the same. So control copy, and I could do test equals request dot post, pass in the URL, and then let's give it an empty JSON so we can see an error. Test says the response is 400. Basically means that we sent bad data to the server. And I think we can do .content to see what the error was. More or less this describes it. It says that the request body deserializer error, missing field name at line 1 column 2. So if we go back to the source code, right? Employee has a field name. It was missing, and it's telling us that explicitly. So what does that mean? It means that when we create a post and it's based on a struct, it's going to throw a 400 error if the fields needed for the struct are not met. It's also not going to tell you all of the fields needed for the request. So for example, it says that name is missing, but it doesn't say anything about rate. So let's fill in name and see if we get the same error. Name equals Marcus. Test, still get a 400. Content, we have a different error. Request body deserializer error, missing field rate at line 1, column 18. Okay, so now we know that name is satisfied. We got a different error, and we're missing rate, which we know because it corresponds to employee. Didn't mean to do that. So let's give it a rate, and let's make the rate something outrageous because I think I'm passing 2 there. Let's make the rate 10. Test. Now we have a 200. And what does that mean? Let's do test.json. test.json shows that the return was or is the employee struct deserialized. So if we go back to the source code, which is right here, we see that we take an immutable employee, which we just created based off the post request, and then we change the rate to be the rate that was in the URL. And then we reply and send it back as JSON. And that is what we're seeing here. So boom, that's a post request. And is there anything else I'd like to go over before I end this video? Let's check. I think for this video, I think that's all I'm going to cover for today. But if you want to learn more about Warp, you can go through the examples. They have headers, rejections, futures, a to-do app. And then they have other use cases. So you can do static files, a whole directory. You can create a front end with an HTML template. They have WebSockets, server-side events, TLS, auto-reloading, and debugging. So you can do tracing. Yeah, and with that, that's the end of the video. I hope you liked it. If you did, hit like, subscribe, yada, yada, yada. Aside of that, peace.